Two 4.5 centimeter by 4.5 centimeter metal plates are separated by a 0.18 millimeter thick piece of Teflon. Part A, what is their capacitance? So this is, of course, going to be a parallel plate capacitor. And I'm going to give some dimensions here. I'm going to call the sides length L, and I'll call the separation S. And so we know that the capacitance, this is part A, is in general kappa times the vacuum capacitance, which is kappa times epsilon naught A over the separation. So for us, it's kappa epsilon naught L squared over S. For the particular values that were given there, we would have we'd have to look up Teflon, and in your textbook around page 857, they have a chart called Property of Dielectrics, and in it we see that Teflon has a dielectric constant of 2.1. Epsilon naught is 8.8 times 10 to the minus 12. We should have the right units on that. Pulling from the equation sheet, we find that it's Coulomb square per Newton times meter square. And then the other guy is 4.5 hundredths of a meter squared over 0.18 of a thousandth of a meter. And then we have to grind out the number. This turns out to be 2.09 times 10 to the minus 10 farads, which is probably more commonly written as 0.209 nanofarads. Part B asks, what is the maximum potential difference between the disks? And for that, what we're going to need to know is we're going to know what the maximum field strength is, because at a certain field strength, you'll pull the Teflon apart. And that same chart tells us that the maximum field strength of Teflon is 60 times 10 to the 6 volts per meter. But we also know that the electric field is the voltage over the distance, over the separation. So I should call that over S. So Vmax is Emax times S. 60 times 10 to the 6 volts per meter times 0.18 thousandths of a meter. This is 10,800 volts. Again, probably written as 10.8 kilovolts.